I spent a little time off camera drawing these. There's a, I don't know, peach, orange, something, and some cherries, and a pineapple, I guess. I tried to make a pear. 7 by 7 pixels is not enough to draw a pear. I also made destroyed versions of each that we can use once our snack has gone across them while they are still being displayed. So let's quickly implement those. Where we draw the fruit. It's in draw. Fruit, here we go. So if it is eaten, then okay. So this one 288 with a transparency of 0 is fine because that's this one. But then if it's eaten, it needs to be 304. 304. Let's just use that one for now and run it. Did I do that the wrong way around? If it's eaten, it needs to be 304. Otherwise, it's 288. And I just noticed I need to put the transparency back. Okay, there it is. And then if I eat it, it goes. The background color is the same as the stem color on my orange. But I do need to revisit all the colors in this. This big green block is very distracting, but we'll do that in a later video. Okay, well, it seems to work because you can see the squish of the fruit there. The only thing that I'm concerned about is how long before the snake moves over it does it break. That's actually okay. I can live with that. Okay, so that's the easy part. Eventually we'll do a random thing where each fruit remembers what kind of fruit it is. Screw it, might as well put it in now. New fruit. So let's go available cells. If it's occupied, then this is where we create the fruit. Okay, let's do a local called fruit sprite is equal to math.random, and we have 3 options. And can I do, is this going to just give me an integer value? It should be fine. Okay, so in here we add a new value called sprite, and it's going to be 288 plus our fruit sprite. I'm assuming this can also give us a 0, so we'll check that in a second. I'm coding blind. I didn't test this. We'll see how it goes. Okay, then the other thing is where we now draw the fruit. Instead of hard coding this 288, it's going to be underscore f dot sprite, and then the destroyed version is going to be underscore f dot sprite plus, I think there's 16 across here, plus 16. I broke it. Attempt to perform a arithmetic function, fruit sprite. Fruit spur. Nothing. That's not great. We need to see what this sprite is giving us. Because that's 288. So it needs to be, can this be like a math? Is it what? Math dot floor. I think that's a thing. Too many brackets? Too many brackets. Okay, now it's a pineapple. Now it's a cherry. It's still a cherry. Now it's a nothing. Okay, so this needs to be up to 2. And I still don't know whether it's ever going to give me 0. Pineapple, cherry, 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 cherry. Okay, statistically significant chance that it would have given me an orange by now, and it hasn't. So can we go between 0 and 2? Cherry, cherry, cherry. Orange, orange, cherry, orange, orange, orange. Okay, but now it should be between 0 and 3, because if it's going to give me a decimal number of 2 point something, then it'll be number 2. So I don't see anything. Still don't see anything. Okay, there's a pineapple. Orange, pineapple, 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 orange. Where's my cherry? Is it randomly not giving me? There's a cherry. Okay, we can probably do this in a better fashion, but that works for now. Oh, and then we need to see what happens when I see this bothers me. Why is this blank? Let's quickly do here where we calculate the fruit sprite. Let's quickly do a debug trace of fruit sprite and add to that the value of fruit spur, so we can see what that is. Okay. Fruit sprite. Why did it run so many times? But either way, we're getting values of 0, 1, 2, and 3, so we should actually stop at 2. That's point number 1. Point number 2. Oh, because it's running it for each space. But if it's not occupied, then... Oh, because it's calculating it for each potential fruit. And it's only necessarily getting added if that space is free. When I randomly select that one. So you know what? There's actually a bunch of stuff here happening. Okay, because it's generating it for all the potential fruit. That's fine. That's fine. Okay. Cherry, orange, pineapple, orange, pineapple. That seems okay. Yeah, that's an even distribution. Oh, let's see what happens if I catch it. Oops. I'm bad at snake. Yay. And then psh, psh, psh. Yeah, that's pretty good. Oddly satisfying. We can add sounds later. Okay, what was I going to do? Oh, make the tail of the snake get longer. Now this one may or may not absolutely break the game, because there's a bunch of code we're using the last segment of the snake for. So firstly, in new segment, let's give it the ability to create a new segment without passing it X and Y position, because if we're just making the snake longer, we don't necessarily know what that is. So we're creating a local segment with an X and Y position as it was passed. And if we don't send it any parameters, these will be passed as null. So we can assign null, that's fine. But then before we insert it, we can go if we only need to check one of them. If X position is equal to null, then assume position, in which case we copy segment ahead. So local segment ahead is going to be snake at index the length of snake. So the last one in the chain. Then we copy everything from this. Head dot X position. If you're wondering why I type this out instead of doing like a copy or a duplicate, it's because Lua doesn't have a way of copying things, because everything is by reference. And then if we just say that the new segment is the same as the previous segment, it's literally going to assign it. And that's dangerous, because then if we make changes to one, it's also going to make the changes to the other. So we need to copy. These are all basic types. So we need to essentially just copy the values, not the actual object. Now we're going to add something here. So we're copying everything. The problem is now we've got two snake segments on top of each other in the same spot. We need the last part of the snake to not move until the one on top of it has moved off. In other words, that the new segment that gets added needs to stay in place until the whole snake has moved away from it, so that when the tail gets longer, it essentially just extends from the end of the snake. So we're going to give each segment a new value called isNew, which means we also need to tell it that if we do copy the values from before, no, not here, that's in getter, here. We also need to tell it that all snacks, all segments should have an isNew of false. It doesn't have to technically, because if you ask for if you write an if and you ask for a value that doesn't exist, it sends back null, which is technically false. But this is just a bit cleaner. Now, what do we do with isNew? Because if I run this now, it'll run absolutely fine up until the moment. No, actually, it won't do anything because we still need to call new segment. So when we check eat, mark it as eaten, score gets increased, make snake longer. Here we can now just call new segment and pass nothing, which will default it to that thing where it copies the section in front of it. But now if I run it, it'll catch the piece and explode. The reason it exploded and why it took, I don't know if you noticed, but why it actually takes from when the thing gets eaten, eventually. There we create the new segment. There it breaks. Why? Because we are currently in the move function, right? We only update the directions and movement and stuff of each segment of the snake at the beginning of move. So that's already happened for this, air quotes, cycle. So then when the next cycle updates, it tries to get the direction by looking at the segment and the one underneath it, because they're in the same spot. And it gets directions of 0 and a bunch of things go wrong. So that's why we have that isNew value, because in move, we can tell it, okay, we get segment, and then the segment ahead of it, and then we like calculate direction and move the piece and so on. We only want this to happen if it's not a new segment. So if seg.isNew, the only thing we do is seg.isNew is equal to false. That's all we do. Otherwise, we update it as normal. Right. Something like this. So when it hits the beginning of that next frame and it's supposed to move everything, it'll move all the other sections, but the one underneath it will essentially stay where it is for one more cycle. Okay. And then there's one last thing that we need to do, which I'll indicate in a second. But this should now theoretically, wait for it, our tail should get longer. Boop, and then it just stays there until it starts moving again. But you notice that the tail disappeared while the movement was happening. Watch, watch, watch. There, the tail is gone. The reason for that is the tail is still animating. So when that first iteration, that first in-between T frame happens, where the hell is tail? Oh, it's in draw. It still animates the tail through the body section, through the circles of that segment. So here we go, snake tail. See, it's still multiplying by T. But to make it stick to the back of the snake while the tail isn't moving, at this point, we actually need to go if tail.isNew, then we need to lock the tail X and tail Y position to its maximum. So let's just copy, actually, let's just copy both of these lines and then remove the locals. Like that. But then if it's new, instead of using T, we're using cell size. So it locks it at the maximum position, which is where the end of our snake is going to be sitting for this entire loop. Else, we render it as normal. So these two lines. And then we take out the locals because we've already declared the value up top. And then for the sake of lack of code duplication, we can just set this position to 0, 0, just so that it has a value. And that should now theoretically mean our tail is just going to sit there until it starts moving. Which means, look at this. We can essentially play snake now. We can't die, but look, our snake gets longer as we catch things. So the game is now officially playable. It is minimum viable product. So next, we need to look into collisions with the snake itself, which is going to kill us. And that's going to be a little bit more work, because we need to then create an end game condition. Oh, see there. We need to now create an end game condition so that we can tell the player, oh no, it's game over, you killed yourself. But for now, maybe let's just put in, I've got time in this episode, so let's just put in the conditional that checks, where did I put check eat? Here we go. During updates, we move, we check eat, and then we also check snake collide. Find check eat so that we can put this nearby. This is the end of check eat. I really should learn to move the mouse out of the way so I don't type behind the mouse. Function check eat, check snake collide. Don't need anything. Then this is actually pretty simple. I should just need to go if, no wait, yeah, if occupies the snake, and I compare it to snakehead.x position and snakehead.y position is not equal to null. It means there's something there. Look at that. So let's for now just go debug trace. You have died. Okay. Let me see if this works. Like I said, I'm coding blind. I didn't test this. So now theoretically, if I move in here, okay, testing the wrong thing. So that works. Snake gets longer. And now if I move into a space that is occupied by the snake like that, you have died. You have died, you have died, you have died. Because every tick that it ticks, it's going to have died. That feels like there's a lot of them actually. 17, 16, 16, 16, 17, 16, 17. Okay, wait, let me test it again. Clear this. Run it. Just go down. Left. This should be fine, and then up. Now. Actually, I might still miss it, because we're technically not in that last frame anymore. Why are we dying so often? Okay, we can take out fruit sprite. Find this debug trace we can take out. Because we're returning the first thing that occupies that space, so we're going to hit the snakehead first. And then we're not returning anything after that. Because the snakehead occupies that space, which means it immediately comes back as true. Because it's also going to use that thing to, yeah, you know what we need to do? We need to ignore snakehead. Ignore head, let's just call it ignore head. And then make it an optional parameter by going if ignore head is equal to null, then ignore head is equal to false. Otherwise we would have been passing it, so an end. So that gives it a default value. And then here we go, if these occupy the same location, and then we put a nested if hyphen v is equal to snakehead and not ignore head. Then we return this. Else, wait. There's no else. Now we do need to have an else if here. Else if v is not equal to snakehead, then return the thing. So, because this will return for everything other than the snakehead, this will return for the snakehead if we're not ignoring it. Otherwise, nothing happens, and it'll eventually return null. Let's see. Now I need to eat something first, so that I'm long enough. And now I need to Ouroboros, and it should ignore the snakehead. So, okay, clear. Let's start with fresh. Okay, so here we go, left, down, right, there, it should die. Okay. It's still printing out a whole bunch of you have died. Oh, because we didn't pass it the ignore snakehead thing. Snake collide and ignore snakehead. Okay. Let's try this. Eat something so that my snake is long enough to actually do a loop back on itself. That way. That way. That way. There. Okay. There we go. Went to debug. Snakehead moved, turned. You have died. It works. Okay. So now, in here, we can put one of our first conditions that make the game go game over. The other one's going to be when we move off the side of the board. And then we need to write a little state machine that can handle when it's game over and when it's not. And then we're going to add high scores. And then we need to fix all the colors because it looks a bit jank. And then maybe add some sound effects. This is getting exciting. We're getting to the point where the game actually starts working now.